Hi, hello everyone. Good evening.
Hi, hello everyone.
How
Good
are you all
evening.
doing? I know that you all are doing super good, right? So this is your Ameer sir, Master Teacher of Physics at Vedantu. Now, quickly tell me once again. I'm asking you in this Christmas Eve, how all you are doing? Are you all doing good? Fine, amazing. So hi Kev, hi Durai. So is it fine with you all? Good evening, Kaif. Good evening, Aisha. Good evening, good evening. So tell me, no, none has said how your day is going on. So if you all are going to tell me, yes, it's fine and it's amazing, I'll be so happy to start the class. Okay, so here we go. So why we are all over here? Because we are just 60 days away from our exam dates, right? So JEE and NEET exam is going to happen soon. So don't you think we all want to prepare so amazing fashion, right? So that's why here we are with the sprint series. In this sprint series, we are going to discuss each and every topics that is going to come for this JEE and NEET, right? In a topic wise fashion. So as it is in a topic wise fashion, you can actually make our schedule as your schedule, because okay, whenever I'm telling that okay, today it's electrostatics, right? So whenever we say that it's electrostatics, you can actually prepare those particular topic before coming here, and here we are going to do lot many objective questions from the chapter. So some might be thinking, okay, I have a little bit more to complete the theory, right? So don't worry at all. Why? Because along with the questions, I will also be explaining you what the entire theory related to it. Okay, so one more thing that I have to add regarding me is before we start with the classes, right? So I'm from Kerala, so I really or barely know the language Hindi. So shall we all do the classroom in English? Will it be fine for you all? And there is some crowd from South India, so I think it'll be better we stick on to the language of English. Is it fine for everyone? Kef, Aisha, everyone. Is it fine? Okay, so I think it's gonna be fine. So thank you so much. So here we go with the very first question here. Zara? Yes, Zara. Here we go. So the first question goes like this, right? A positive charge Q exert a force of minus 20, sorry, not 20, minus 0.2 Newton on another charge of minus 2Q. The question is find the magnitude of each charge, right? If the distance separating them is equal to 0.5 meters or 50 centimeters, right? Okay, so let's take a fresh page and do this. So let us do like this. We have a charge of Q, we have another charge of minus 2Q, right? The distance between them is 50 centimeters, or we can say that it's 0.5 meters, right? Okay, so what other information is given? So the force is given as 0.2, which means on this minus Q, the force experience is equal to 0.2 Newton, right? Okay, so these are the informations given and you are supposed to find out the charges, right? Isn't it simple? Because here you simply have to use which law? The Coulomb's law, which gives you the force that is happening between two charges, right? So what's the force formula according to Coulomb's law? That is equal to 1 by 4 pi epsilon 0 q1 q2 divided by r square. Yes, okay, let's start supplying the values. So it is 0.2 is equal to, what's 1 by 4 pi epsilon 0 value, everyone? Tell me what's the value, Kaif, Zara? What is the value? It is 9 into 10 power 9. Yes or no? Yes. And charges, one charge is Q and the another charge is 2Q. Okay, let's only concentrate on the magnitude, okay, because here we are only asked to find out what the value for the charges. So direction has nothing to do here, we only be focusing on the magnitude. Great. Divided by square of the distance that happens between them. What's the distance? Here we can find out the distance is 0.5, that is equal to 1 by 2. So squaring, you will be getting it as 1 by 4, right? 0.5 is 1 by 2, 1 by 2 square. So I hope it's fine till this particular part. everyone? Okay, now what is there? You simply have to rearrange the things and get your answer. That's it. So this is equal to 0.2 divided by 4, right? And how much you will be getting? Divided by 9 into 10 power 9 into 9 into 10 power 9. Then what's remaining? So this 2 also will be coming down. Okay, so till this I hope it's fine. If this 9 is not clear, I'll rub it again and do it for you. So 10 power 9, okay, into 2. That is equal to q square. So if you want to get q, you will have to take the square root of this. So square root of 0.2 by 4 into 9 into 10 power 9 into 0.2. So just do the math, and after doing the math you will get the charge as 1.66 into 10 power minus 6, which means this value we are going to get it as 1.66 into 10 power minus 6. Right? You all can hear me, right, Kev? Is it visible? Should I have to zoom the questions? You are not, isn't it visible? I think it's visible, right, to everyone? Now, what about now? Is it fine? Okay, good. So I think the answer is a q value we got, and the other charges, which one? What's the other charge? If one is q, the other charge is 2q, so it is 2 times 1.66 into 10 power minus 6, right? This is 2q. So this is almost going to be 3.22 something. Okay, so 2q is equal to 3.23 into 10 power minus 6. All good, super fine. Shall we jump to the next question? Okay, so here we go. So this is our next question. So I think it is better, don't you think, that if a question is being there, okay, if you get a question, don't you think that pictographically representing it is a more easy way to solve it? Don't you think so, Kaif? And everyone? Hi, Sankita. So I think that's a better. So whenever you get a question, okay, try to picturize it, so you'll be getting a better idea regarding that. So here we have the question. Next, what distance must separate two charges? You have two charges in order to have an electric potential energy with a magnitude of 5 joules in the system of two charges. Now, in order to solve this, okay, you actually need to know one formula, or I'll give you some 30 seconds of time. Can you all try doing this particular question? Can you all try doing this particular question? Everyone, be energetic. Okay, I'll wear my specs also. So now, be energetic and tell me, can you all do this? 30 seconds, now it became 20 seconds. I'm waiting for your answers, everyone. It's a question regarding the potential energy. So if you really know the equation for potential energy, this can be simply solved just like that. So I think it's better I'll give you an idea. Okay, so those who are doing there can continue doing it. So it's like two charges are there, right? Okay, and if you are having two charges, how will you calculate the potential energy? It's given by 1 by 4 pi epsilon 0 q1 q2 by r square, right? Any doubt in this? No. Now let us substitute the information whatever it is given. The potential energy is given as 5. What is 1 by 4 pi epsilon 0? 9 into 10 power 9. We all know that. Charges are 5.6 into 10 power minus 4 and 6.3 into 10 power minus 4. Again, we are concentrating on the magnitude, right? Okay, so let's not focus on the signs here. So it's 5.6 into 6.3, 10 power minus 4 into 10 power minus 4, it's 10 power minus 8 divided by r. Okay, so the only unknown is r, and that itself has to be found out here, right? So rearranging, r will come up. So it is almost 5.6 by 5, almost around 1.2 something. So 9 into 1.2, almost 9. 6 nines are how much? 6 into 9, almost 54, but it will be almost coming around 6.2 because we have actually approximated, right? So we'll be having some 63.5 into 10 power 9 into 10 power minus 8 is 10 power 1, right? Or we can write it as 6.35 into 10 power 2 meters. So which option we can go with? We can go with the option C as our answer. Are you all enjoying? Okay, when I ask you are you all enjoying, you have to tell me that whether are you all understanding, because understanding physics itself is the enjoyment. Okay, if you enjoy, it's like you are going to solve one question in the JEE and NEET. Is it clear, everyone? Is it clear? Okay, so I'm going to assume that yes, you all are doing good and did this part and did this question and understood it. Now let's hit the next question. It's like this. The distance AB, okay, the distance AB between the two charges given here as a Q1 and Q2 as a 5 meter. How much work must be done to move the charge Q2, you have the charge Q2 here, to a point C where the distance is 2.5 meter more. Okay, very good, Manchula. Now the question is regarding the work that has to be done. How will you find the work done, or what is the basic equation to find out the work done by an external force? Work done is equal to change in potential energy, final potential minus initial potential energy. So here also basically we have to use the equation of finding out the potential energy like we did in the previous case, right? Okay, so let's find out the potential energy when you take the point B, okay, or the charge Q to the point C. Okay, what's the formula? That's equal to 1 by 4 pi epsilon 0, right? That's 1 by 4 pi epsilon 0. You are keeping this Q2 to here, right? Okay, into the charge is Q2 is equal to, I think it's 5 into 10 power minus 6. 5 into 10 power minus 6. It is minus 3 into 10 power minus 6, right? The whole divided by R, that is equal to 7.5. This is the final potential energy. Now initially where it was kept, it is kept at the point B. You have to find the potential energy there. Yes or no, everyone? Yes, tell me quick. Yes, so U1 is the initial potential energy when you are keeping the charge Q2 at the point B. So what's the formula again? That is 1 by 4 pi epsilon 0. We know that the equation is going to be the same between the basic formula, only the distance is changing, right? So it's 1 by 4 pi epsilon 0. Then it's Q1 and Q2. Q1 and Q2 remain the same. 5 into 10 power minus 6 minus 3 into 10 power minus 6. Only the distance changes. It's fine. So we got this U2 and this U1. So work done is equal to U2 minus U1, right? So if it is U2 minus U1, if you do, whatever it is common, we can take it outside. 1 by 4 pi epsilon 0, that is 9 into 10 power 9. That's common. Then what is common? The charges along with the sign. So this 3 comes with minus, so I'm putting the minus here itself. So 5 into 10 power minus 6 into 3 into 10 power minus 6, all are common. In the bracket you have 1 by 7.5 minus 1 by 5, right? So here if you rub this part, we will be getting it as what? It has 5 here. Is it clear? So it is 1 by 7.5 minus 1 by 5. I know that you all are super good in doing the math, right? Yes or no? Yes. So if we do the math, what is the final answer we are going to get? The final answer is going to be simply 9 into 10 power minus 3. So I hope you have seen the answer slide. It's simply 9 into 10 power minus 3, which is option C. It's very simple, right? Though we have a lot many steps here and there, but once we come to the final part and once we listen to the explanation, don't you think it's simple? So just like this, all the questions of physics are super simple. You just have to give your mind, okay, and just try to understand the concept and apply it. The answer will be in your hand. Okay, so I hope everything is fine. No doubts are there. So let's jump to the next. Here we go with the next question. This is a very simple question. It is mainly connected to mathematics part. Let's solve this. You have a charge q. It is divided into two parts, q and q minus q. Okay, a small q and capital Q minus q, separated by a distance r, right? So let's draw this. So you have a charge q and you have a charge of q minus q. This is splitted from capital Q. So from capital Q, if I'm taking small q charge, the remaining charge will be capital Q minus q. We know that. It's very simple. Now the distance between them is kept as r here. Okay. Now till here I hope everyone did this. Now what is remaining is, if the force between the two charges, let's write the equation for force. That's 1 by 4 pi epsilon 0 q capital Q minus q divided by r square. This is equation for force, right? If the force between the two charges maximum, okay, so from where this concept of maximum and minimum is coming, it's very simple. Now listen, here you can see that the force is totally dependent upon the small charge q here, right? Yes or no? Yes. Now as the small q changes, the force will also be changing, which means if you simply plot a random graph between force and the q here, right, you can see that as q value changes, force will be changing. So I just drew a random graph like this. But in this random graph, you can see that at a particular point, the force will be having the maximum point. Okay, whatever may be the shape of the graph, at a particular point, force will be having the maximum. At that maximum point, what is the speciality? What is the speciality of that maximum point? Who's going to tell me? The speciality of that maximum point is the slope is 0, right? The slope of force q graph is 0, which means how will you express the slope? That is df by dq, it's equal to 0 at the maximum position. So the point where the force is maximum, df by dq will be equal to 0. I hope you all got this concept, right? Okay, now let us proceed from here. So df by dq, it has to be 0. F is this, right? So in this f, if you try to do the differentiation, 1 by 4 pi epsilon 0 by r square, it's a constant. So let me write it outside. 1 by 4 pi epsilon 0 r square, it's a constant. Now what is remaining is d by dq of q into capital Q minus q. It's equal to 0. Okay, obviously if you multiply this constant here with 0, it's going to be 0 itself. Now let us do the differentiation, okay, by using the multiplication method. So first one, q into the differentiation of capital Q minus q. What is differentiation of capital Q minus q? Capital Q is a constant, okay, minus q, d by dq of minus q, it's minus 1, so minus q, plus second one, capital Q minus q into differentiation of the small q, that's 1, it's equal to 0, right? So what do you get here? Capital Q minus 2q equal to 0, or let me write it here because of the lack of space. I hope it's totally fine. Okay, so 2q is equal to q and the small q is equal to capital Q by 2. So we have the option A as our answer. Is it clear, everyone? Any doubts you have, you can ask me now in the chat box. We all are live and I'm here to solve all your doubts. So I'll be so happy to solve your doubts if you have any. Or else it's time to jump to the next question. Okay, fine. Let's move to the next. Here the next question is, an electric field strength created by a charge q is measured to be 40 Newton per coulomb. Okay, so you have a charge q, the electric field is given and the distance from where the electric field is measured is also given. Question is, what is the new electric field, right, when the distance from q is, now the distance is changed, right, and the value for the charge is also doubled. In that fashion, what is the new electric field going to be? Let's write the formula for electric field, right? For a point charge, the electric field is given as 1 by 4 pi epsilon 0 q divided by r square. Okay, yes. And the value for electric field, according to our question, it's 40. This is equal to, let's write it as 1 by 4 pi epsilon 0 itself, q divided by r is 0.2. It's not so visible. So r is equal to 0.2 the whole square. Right? Okay. Now what we have here is, the question is, what is the new value for electric field? Let's call it as E dash. Okay. It is 1 by 4 pi epsilon 0. The charge became double, it's 2q. And the distance is 0.4. Here it was 0.2, now it became 0.4. 0.4, let me write it as 2 times 0.2 the whole square, so that it will be good for comparison. Now, rearranging, this extra 2 comes outside. 2 square, let us write it as 4 outside. What it remains is q divided by 4 pi epsilon 0, 0.2 the whole square. Now, if you look at the above equation, 1 by 4 pi epsilon 0, q divided by 0.2 the whole square was found to be how much? We got it as 40. Right? So, I am substituting the same here as 40. So, this is 2 by 4 into 40. Okay. So, what's 40 by 4? That's 10 into 2, how much? It's 20. So, we have the option B as our answer. Is it clear to everyone? Okay. Okay, Vishal, I'm so happy to hear that. If you are loving this, okay, and if you are understanding thing, that's the best thing that as a teacher I can listen to. So now tell me, is it clear to everyone till this part? Data pirate, the top, which part you are having doubts, you can tell me now so that we can clear it out. Okay, yes, Abu, very good, amazing. So let's do the next question. Okay, so here we go. So the question goes like this. You are having a point charge. No doubts? Okay, amazing, very good, Abu. Let's do this question, right? So we are having a point charge, okay, which is at a distance of 5 centimeter directly above the center of a square of side 10 centimeter. It's a square. What is the magnitude of the electric flux? What is electric flux? The total number of electric field lines passing. That is defined as electric flux, right? Okay. Now let us understand this in a better fashion. So let me try drawing you a small cube like this. So here we have the cube. I hope whatever I'm drawing, it's gonna be a cube because I'm not so good in drawing. Anyway, yes, I succeeded in making a cube here, right? Okay. Now this is let's say this is the square which is being talked in this particular question. So here we have a square. On top of the square we are keeping a charge like this. Can you see? Okay, a charge is being kept. Question is the total flux that is passing through that square. So in order to produce a uniform shape around the charge, right, I made it as a cube from that particular square, right, by keeping the charge exactly at the center of the cube. Okay, we all know that the total flux that is produced by a single charge is equal to, we all know how much it is, q by epsilon 0. This is the total field lines coming out from a charge. We all have learned this, right, Gauss law? Okay, good. Now my next question is, if it is total is q by epsilon 0, how much is going to pass through this small square portion that you can see here? Q by epsilon 0 is totally divided for the entire cube, right? So that square is only a single part of the cube, so 1/6 will be passing through that particular square, right? Now just apply the values and get your answer, because charge is given as 10 into 10 power minus 6, 10 microcoulomb. by 6 into, what is epsilon 0? 8.85 into 10 power minus 12, right? So which option we can get? It is simply the option D we are going to get after doing the math, which is 1.88 into 10 power 5. So is everyone clear till this part? Have you all enjoyed understanding the physics till now? Everyone? Are you all understanding all the concepts? Okay, so I'm going to really think that you all have enjoyed till this particular part. Okay, so understood all the concepts and you were loving it. So thank you so much. Okay, and now small thing that I want to ask you for all these classes is, okay, small things that you can do for me is, if you have liked this particular session, please don't forget to hit the like button, okay, that thumbs up button. I don't think it's a very huge job. Now if you think that just like you, your friends are also going to get benefited from this class, please do share with them, and please do let them know about the sprint series which is going on. And one last thing, which is the important thing that I want to say is, right, so please don't forget to subscribe, because once you subscribe, you will be getting the notifications from this particular channel whenever the class is going on air. Okay, so I think you're going to love it. You will be loving each and every sessions, because in each and every sessions we are going to cover each and every chapters of 11th and 12th. So before we reach the JEE exam, we'll be completing the entire portions of 11th and 12th. Okay, so by thinking that everyone have enjoyed this, we're gonna say bye bye for the time being and going to say good night. So bye everyone, take care, and good night till we meet next time.